Good afternoon, everybody. Welcome to the class of physics. Today we're going to do a throwback to our wonderful time that we spent in Spain last year in October. The purpose of today is that you can calculate something about the force to hold balls. The question that I give to you is how much force is needed to hold a bolos? Alexander, do you remember what a bolos is?
Yeah, the bolos was a wooden thing you would throw to some pins to gain points in a Murcian bowling game.
Exactly. It's a wooden ball that we have to roll over a certain distance. The formula to calculate the gravity is the F stands for force, exactly. The Z stands for zwaartekracht. It's a Dutch word, but in English it's gravity. And how do you calculate the force of the gravity? You have to multiply the mass by the gravitational constant. Kat, gravitational constant. Do you know what that means?
It's the force that pulls you to the Earth.
Exactly. The Earth is has an influence on every object that is on the Earth. So the Earth is pulling everything down by 9.81 Newton per kilo. So M is the international symbol for, I think you know that, M stands for, Sarah?
Newton? M. So
The
mass.
M stands for mass.
Yeah.
Correct. G is a gravitational constant, and the Z, I told you already, is from the Dutch word zwaartekracht, but it means gravity. Now let's calculate the gravity force on a bolos. Therefore you need to know the mass, and the mass of a bolos is, I heard it from the colleagues in Spain, is around 1 kilo. So, Emily, do you want to calculate for us the gravitational force on the balls?
Sure. That is.
You can write it. Okay. So we take the mass, exactly 1.10 kilograms times the gravitational constant. What is the solution? Soon?
10.8 Newton.
10.8 Newton. Exactly. Thank you, Emily. So that means that if you want to hold a bolos, your force of your muscles in your biceps must exceed the 10.8, approximately 11 Newton. Then you have enough force to hold the balls. Okay. Clear? Maybe you want to go to the moon and you want to play the Bolos Murcianos on the moon. That will be a difference. What will be the difference, Maya? When you play it on Earth or when you play it on the moon?
The gravity on the moon is different, and I believe it was 6 times less than on Earth.
Exactly. When you play Bolos Murcianos on the moon is pulling 6 times less than 6. The moon is attracting the balls a lot less than on the Earth. So the gravitational constant of the moon is, I think it's somewhere, yes, it's 1.62 Newton. So Simon, can you calculate for us the gravitational force on the balls when we are on the moon?
Yes. Do I have to call it?
Yes, you can write it down. So we take the gravitational constant times the mass. The mass stays the same.
How much was it?
1.78.
1.78 Newton. Thank you, that's correct. Okay for everybody? Then we can go to the next thing. How much work is needed to roll a bolus over a distance of 18 meters? When you play the Bolos Murcianos, you have to throw the ball to reach the pins, and the pins are located 18 meters behind the line where you stand. The formula for work, V stands W, W stands for work, F is the symbol for force, and D stands for the distance. But when we roll an object over the ground, there is some friction. And the friction is slowing down the movement of the object. So when you play Bolos Murcianos, you play it on a sandy ground with some little stones, and the gravity, the friction on a sandy surface is, I wrote it down, is 0.55. So the formula for the work becomes mu, it's a Greek letter in our alphabet, it's the letter M, times the force times the distance. So, who wants to come and calculate the work for me? I think Lotte can do that. We shall help, no worries. So the mu, the Greek letter, stands for the friction, and that was 0.55 times the force. And what is the formula for the force? It was the mass times the gravitational constant. Yes, so we take another time 1.10 kilograms times 9.81 Newton kilogram times the distance, and the distance is 18 meters. Correct. What is the solution? Did anybody already calculate it? Zoe?
I have 17.62.
Nee. Ik was aan het kijken. Ik kom hier op 107 joule uit. Dat gaan we erop uitkijken. So, what is the solution? Zoe?
That is 106.83.
So we take 107 joule. Joule is the eenheid, Okay, thank you so much, Lotte. And the last thing that I want to teach you about is how much energy is needed to throw a ball through the air. Then we have to think about the kinetic energy. The kinetic energy is a simple formula. You have the mass times the velocity squared, and we divide it by 2. But to know the exact velocity of an object that you throw in the air is very hard. But there is a solution. We can replace the velocity squared by another formula, the distance times the gravitational constant, and it will be exactly the same. So the formula for the kinetic energy becomes this one: mass times distance times gravitational constant divided by 2. Now we can calculate the amount of energy needed to throw the balls towards the bowling pins who are located 80 meters behind. Alexander, can you calculate it for us?
What was the solution?
97.
90,
97.
0.1, I think.
Yeah, 0.1.
Yes. Exactly. Okay, Alexander, thank you. So far, the lesson of physics today. Thank you for your attention, and I hope you will remember the formulas for your whole life long. So, thank you so much.